In this video, we will look at the basics of R. We'll introduce the R software, what it means to program in R, and just talk a little bit about what we're going to be doing in the course. So what's this course all about? Well, it's all about programming, and programming specifically in the statistical software called R. So R has been around since about 2000 roughly, and it is a software that was traditionally just used to do statistical analyses. So if I wanted to do a linear regression model or something like that, I could use R. Nowadays, it's used for a lot more than that. With the advent of data science, R has grown quite substantially in its capabilities. What we're going to focus on is doing things with data. So what I mean by data is having a data set. Usually we think about a rectangular data set where the rows would be observations and the columns would be variables. And so we're going to need to be able to write code in R that will be able to do some things like read in data, or perhaps we'll create the data in R itself. We need to be able to write code that would then summarize that data. So maybe provide us with summary statistics like means, medians, etc. Or perhaps create a histogram or a scatter plot, those kinds of things. Occasionally, we're going to want to do some data analysis. We're not going to focus on this too much in this particular course. But if we did want to fit a linear regression model, that kind of thing, we could write code that would do that. And then lastly, we want to be able to communicate the results from our analysis. So we want to be able to create reports very easily, maybe a PDF, an HTML document, or slides, for instance, that would communicate what we're doing. And so we'll look at how to use R to do those kinds of things. And in fact, the slides that we're looking at right here were created through R. And so if we're learning how to write code in R, what that means is that we need to determine the proper syntax and functions and things that we need to learn about in order to submit those to R to be evaluated. And so, for instance, if I want to find the mean of some numeric data, I can use the mean function, which would require me to use the keyword mean, have an open parenthesis, provide the data as the next argument, and then a closed parenthesis. And so we're going to have to learn about this type of syntax. How do I determine which function I want to use, and then what its arguments need to be? If I want to create a scatter plot between, say, speed and distance for a particular data set, I can use this plot function, and then I can give it my x as my first argument and my y as my second argument. So again, most of what we're going to be doing is determining how to figure out this syntax and then how to access, say, this speed column of this data set and this distance column of that data set. And in the end, what we're going to do, right, we're going to write this code, we're going to submit it to R, and R is actually going to evaluate the code. As long as it is syntactically correct and all the arguments make sense, it will then spit out a result, or we'll be able to save the result for further use. Okay, so we want to learn how to program in R. Where do we start? Well, of course, we're going to start with R, and then what we're going to do is utilize this program called RStudio, which is an integrative development environment that sits on top of R, essentially. It's kind of like a GUI, if you've heard of those things. That just makes programming in R a little bit easier. And so the first steps are to install R and then install RStudio. And one great thing about R is it's available for any platform, Windows, Linux, Mac, as well as RStudio. We'll talk about how to utilize the RStudio interface and what the important parts of that happen to be. And then we'll start to get into actually programming in R, learning about syntax, learning about different types of objects, and then how to access those things. So that's our plan for this first sort of section of the course. So you might ask yourselves, well, why am I in this course learning about R? Well, R is fantastic because it's free, it's open source, and it's available on any and all platforms that you can think about. Not only that, but there are a ton of what are called packages that allow you to do really easy modeling. So if you want to do regression modeling, you want to do random forests, whatever, there's tons of packages for doing visualizations, so making really nice plots, doing really easy data manipulation, and those kinds of things. So these things called packages are essentially just groups of functions or data sets or whatever they happen to be that are all around some topic. And basically anybody can create a package and submit it, and then people can utilize that code. So it's a really nice way to have access to a lot of different methods. Not only that, but statisticians tend to use R quite a bit. And so if a new method is created, a new way to analyze data is created, most of the time there's going to be an R package that would correspond to that. And so you'd get access to the newest methods as soon as possible. There's also a fantastic online community, mostly through Stack Overflow. So Stack Overflow has questions that people that are programming R will post, and then users of R will go in and answer them. And so almost any question that you could come up with will be answered here. So I could say how to transpose a data frame, for instance. And no matter what you type in there, there's almost always going to be a reasonable response that will get you at least started on what you want. So again, there's this great community that will help you learn R as you're going. Oops. There's also a very vibrant community that shares what they do in R. So if you are interested in seeing what some people are up to in R, you can go to R Bloggers. That's a website that just has people post analyses and different things that they do that they find interesting. And like we mentioned before, what's really great about R is the ability to communicate your results to lots of people. So you can easily create PDFs, slides, etc. And not only that, but since R is free and available on all major platforms, you can essentially give your files to other people and they can use them no matter what kind of computer they're on. Okay, so let's start with RStudio. So hopefully at this point you've installed R and now you've installed RStudio. And we want to learn about what we're seeing when we look at RStudio. And so there's four major areas that you're going to end up dealing with: the scripting and viewing area, environment history, plots, packages, and then the console. So let's jump into that. So this is my RStudio. It might look a little bit different from yours, but it's just some visual formatting. But you can see that there are essentially four major rectangles around here, right? So the most important one is probably the console. This is where you actually go and submit code. So if I wanted to find the mean of something, this is where you can actually submit it to be evaluated by R. Up here in the top left, this is where you'll find things like File Navigator. Any plots you make would show up here. So a nice way to view those. You can also save them up here, those kinds of things. You have information about the different packages that you have at your disposal. We'll talk about packages more later. And you also have your help files. So if I wanted to find, say, help for the median function, I could type help and it would come up here and tell me about the types of arguments that I need in order to actually use that function. Not only that, but it would tell me about what I'm going to get returned and then give me a few examples on how to use it. So that's a really nice window to have up there. Over here in the bottom right, this is my script editor window. So if I'm actually writing a program, this is where I might write the program so that I have all of the code to be saved for later. If I just type my code into the console, it's really hard to go back and get all this code and make it easily run again. So like I could go back and copy this and put it somewhere, but then I'm going to have all this formatting. That's a problem that I'd have to get rid of. I'd have to get rid of all the output, and now I'd be able to rerun this code. So what we tend to do is write code in what's called a script, or maybe a markdown file, which we'll talk about later. And then from here, you can take your code, copy and paste it over, or you can take your code, hit this run button, or use hotkeys to submit that code to the console. This is a really important window. This is where we'll usually be working from. Not only that, but we will be able to look up here in this top right where this has an environment tab, and this tells us any of the R objects that we already have created and stored. So if I create something, we'll talk about creating things in a little bit. If I create a numeric vector with these three values in it, it pops up here and shows me that I have an object called X that I have access to now. I also have an object called NHL Shift that I have access to now. And so it's a really useful tab up here to see what you're doing. And then there's some more advanced things about connecting to databases using Git or GitHub and your past history of your code. But these are the four major windows that you're going to be dealing with in RStudio. And you can move these things around and make them look different by going to Tools, Global Options. If you do that, you end up with all these options where you're allowed, where you can change things. So pane layout, allows you to change where your things show up. So you can choose my source over here, and that would switch my window that's over here to over here, and my console over there. So you can move these things around if you want, however you're comfortable with. You can go to the Appearance tab, change the size of your font, change the themes and all that kind of stuff to make it sort of look nice for you. And then the other thing that I recommend is going into this code section and clicking soft wrap R source files. And that just means that whenever you have a really long line of code like I have down here on Penn's game, this would continue to run off the screen over here, but since I'm soft wrapping, it brings the line down here. So I can see the whole thing even if it's a really long line of code. So again, I would check soft wraps R source files. But that's the basic RStudio interface. Again, the major panes that we're going to care about here would be the environment tab up here. The plots and help are very, very useful here. The console where we actually submit code to be evaluated, and then our script editor over here. And so here's just a screenshot about what we just talked about for changing your options for your RStudio appearance. Okay, so how do we use R? Well, again, the console is where you actually go to evaluate code. And so you can just use R as a really fancy calculator. It can do any mathematical operation that you can think of. So if I just want to do some simple addition, I would type 3 plus 7 into the console. It would pop out 10. I could do 10 times e to the 3. So e, Euler's number, exp is the function to get that. So I'm doing e to the 3 times 10. Gives me a number. Log, by default in R, is the natural log. And then pi is that specific numerical constant that you have undoubtedly seen before. So anyway, you can utilize R just as sort of a calculator if you want. But like we said a minute ago, what we usually want to do is keep the code that we submit for later use. I want to be able to go back and rerun my analysis and double check things or change something and then run it again. And so what we do is we write code in what's called a script. Then we save that code for later use. Don't type directly into the console. What we usually do is highlight the code that we want in our script. We either hit the run button, we use hotkeys like Control Enter or Command Enter to actually submit the code to the console. So here's an example program about hockey data. So I've read in this hockey data already. And since I've read that in, I might want to now what's called filter that data set. So this is going to subset the rows. So I'm going to filter the shift data set where only the team is Pitt, so the Pittsburgh Penguins. And then I'm going to filter where only the period is equal to 1. So I only want to return the first period. And then I'm going to filter by a specific game ID. And so this is going to return a subset of my data. But again, what we usually do is we write our code over here and then we would submit it to our console. So I submitted this using hotkeys. So if you're on that line and you submit it, it sends it over there. Again, you can use the run button up here if you want. And if you want to be really specific about what you're submitting, you can highlight just certain chunks. So I could just highlight this first line and submit that. And it would only do that little bit there. Okay, so what might be useful to do at this point would be to try to open up a new R script yourself. And you can do that by going to File, New File, R script. So if we go in here, File, New File, R script, or you can see that there's a hotkey to get a new script, Control-Shift-N. If you click that, you get a blank script file where you can then start putting in R code. So I might type plot cars, and then again I can use hotkeys to send that to the old console to be evaluated. What I'd want to do then would be save this particular file. So you can save as, usually you just save it as a .r file. So I might just save this in my R basics folder, .r. Now I'd have this code for later use. I could bring that file back up. temp.r. I have all the code that you might write there. And so I just wanted to give you an example of a very basic program here. just to see what a very small final program might look like. So the first thing I'm doing up here at the top in this particular program is I'm reading in packages. So library reads in a particular package. Remember that packages are sort of sets of functions that are all around some sort of topic. So the tidyverse actually has a whole bunch of packages within it that deal with data manipulation, plotting, and those kinds of things. And these other ones we actually don't need for this particular example. Then I'm running this particular line of code to read in a data set. So I'm reading a comma separated value file. So CSV stands for comma separated value. I'm pointing to that file, the physical location on my computer. And now once I've run that code, I have an object up here called NHL Shift that has shift data from particular games, I believe from 2018. And so you can see that it has a bunch of information there. So this would be a data set that we would then want to do some sort of analysis on. And so what I'm doing at this point is I'm just grabbing a single period from a single game, and I'm using the storage arrow to save this in an object called pens game. And now you can see that I have this subset of my bigger data set. So this one only has 115 observations with the 16 variables, whereas my NHL Shift data had way more. What I'm doing from there would be doing some basic modification of particular variables. So there's a variable in this data set called last name. And so what I'm doing is I'm modifying that just for plotting purposes. And now I'm going to go down here and I'm going to plot it. So ggplot is a specific function from the tidyverse that allows us to do really easy plots. If I run that, I can now see that this is a shift data plot for this particular period. So wherever this line appears, that's who was on the ice for a particular time period. So I have the start time on the x-axis, the player name over here, and wherever a line segment is, they were on the ice at that particular time. So again, this is just a very basic program that shows some of the capabilities of R. We mentioned before that we'd also want to be able to do reports and sort of easily produce output in either PDF, HTML, etc. So here, we're going to learn about using R Markdown. So you'll notice that this is a .rmd file, not a .r file. And so this is a Markdown file, which is an easy way to interweave text and code. And basically, here's some formatted text. Here's some R code, formatted text, R code. And when I run this, it's called knitting it. When I knit this file, it's going to run all that R code, format all that text, and produce a nice actual document. So again, this is what we're going to work towards. We want to be able to get to this point where we can take some data set, we can do a quick analysis with it, maybe just a summary of it through statistics and visuals, and then create a basic report with it. Okay, so hopefully you were able to do that. So let's just talk a little bit more about some of the aspects of R. R is what's called an object-oriented programming language, and that means that these things that we're saving, that we have up here in our global environment, these are called R objects. And depending on what kind of object you are, R will know how to do certain things. So, for instance, cars, you can run this function on cars. Cars is a built-in object that exists in R. If I type in cars and submit it to the console, you'll see that this is what it prints out. So if I want to know what type of object R is, the str function can tell me what it is. And so this is a data frame. That's a very specific type of object in R, mostly used for holding data sets. And now R, when you do things to cars, since it's a data frame, it will know how to do certain actions on that. So if I run print on cars, it's going to look at the type of object it is. It's a data frame, and it will know how to print that out. If I want to run plot on the cars object, it will look at the type of object it is and then try to figure out what to do based off of that. So just go in here. We already did plot cars, but we'll do it again. So if we plot cars, it automatically puts the first variable as an X, the second variable as the Y, and creates a scatter plot. It's doing that based on the fact that cars is a data frame. Another built-in object is called iris. Iris has a few more variables, but it's the same idea. This is a data frame It has 5 variables, 4 of which are numeric, and then 1 is what's called a factor. And yet, even though this has 5 variables, not 2, if I do plot of iris, it knows what to do with that to produce something meaningful. So this is what we mean by object-oriented. These things that we're saving up here will have a specific type of object that they are, and then we can run a function like plot on iris. We could run plot on G, and it's going to try to figure out what to do. And so that's kind of one of the nice things about R. It has this object-oriented structure that allows it to sort of figure out some of the stuff on its own. And so this is just that code for the structure of the iris data set. And again, when we run plot on this kind of thing, it figures out what to do itself. So we'll take advantage of these object-oriented abilities of R as we go. Just to also mention here how to create your R object. We've seen it in our programs a little bit here, but we have this storage arrow. So this is just the sort of less than sign and a dash. This is the way to create an R object, generally speaking. So I'm creating here an R object called AVG that is storing in it the result of this computation. And so if I actually just run this code here, so if I do AVG store, and I'm going to have different numbers, but that's okay. Run that code. Notice that nothing gets printed out to the console, and that's because I've saved it in this object. And by default, for this particular kind of object, it does not print things out. So I now have this up here in my global environment. If I type AVG in, though, I have the average of these. Sorry, this actually isn't an average. I typed it in wrong. Yes, I did. We don't want the C there. The C is creating a vector of 3 things, and I'm dividing each element by 3. So this would give us the average of those 3 things. There we go. You can also store things like character strings. You don't have to just be working with numeric data. And so we can do that with this, again, this storage arrow that's going to store the store this string in the object called words. Okay, so hopefully you have some idea what we're doing in R. We'll now take some questions.